Hi, today we discuss proportionalities. And proportionalities are a mathematical concept that uses the proportional to sign. It looks a bit like a fish. And they're much like equalities, which is a concept that I think we're all much more familiar with, which uses the equal sign. And a lot of science is described in terms of equalities for ideal gases. We have PV equals nRT, where P is the pressure, V with a capital V is the volume, N is the number of moles, R is the gas constant, and T is the absolute temperature, usually expressed in the unit Kelvin. Temperature connects to the concept of energy. When you have more energy, you have more temperature. 3/2 nRT is equal to the lateral kinetic energy E trans, the lateral kinetic energy, the lateral energy of motion, how fast something is moving up or down or right and left. And this lateral energy of motion is equal to 1/2 times the mass, which is N mm, and times the velocity, average velocity squared. Our expression for average velocity will be VRMS squared. So that's the average velocity. And mm is the molecular mass. And we're used to equalities and doing things with them. For example, we can make an equality, use the equality towards on the right side. We have that 3/2 nRT equals 1/2 N mm VRMS squared. And there's an N on both sides, so they cancel. There's 1/2 on both sides, they cancel, and we end up with a simpler equality, 3RT equals mm VRMS squared. But today we're going to be using proportional relations. And proportional relations can be gotten from equality relations by the following method. Wherever there's an equal sign, we write a proportional sign. And if the variable in question, if the symbol P is a variable, we keep it. P is a variable, volumes vary, numbers of moles can vary. R is a gas constant. It isn't a variable, we don't keep it. T is a variable. And so that's PV equals nRT written as a proportionality. Second one, 3, it's a constant, R is a constant. T is proportional to the variable molecular mass. We can have more than one gas type, VRMS squared. And so this is the same relations now written as proportionalities. And we're going to use this to solve a problem, the problem that I have shown here. So I'll go down here, I'll take this stuff, and then we'll find the various data in the problem and put it down. We're going to first look at the O2 gas. So here is the O2 gas, and I'm going to make a box. And we see that the balloons have a volume of 20 liters. So the O2 gas has a volume of 20 liters. The O2 gas is at 300 K. So I put it at 300 K. And O2 is oxygen, that's 16 grams per mole, its molecular mass is 32 grams per mole. And now we're going to compare that to the argon gas. The argon gas at the end. And the problem says the argon balloon expands upon being heated. So the argon gas started at 20 liters and 300 K, but it gets heated and it's higher temperature and it's a different volume. So what things do we know? We know that the molecular mass of argon is 40 grams per mole. Now there is more data in the problem, and to express the final data, we're going to need the factor line. The factor line compares the two volumes, the values for both the O2 to the argon. In italics it says the pressure inside a balloon is always the same as the pressure outside the balloon. And in this problem, the two balloons are always in the lab. Labs are always at 1 atmosphere pressure, and the factor, therefore, since they're all the same between the two balloons, is 1 times. What else do we know? We're trying to get them so that they have the same average velocity. So they will have the same average velocity. I'll put that here, VRMS. Their factor is 1 times. Average velocity squared will also be 1 times. In the factor line, as opposed to the other lines, the proportionality sign gets replaced with the equal sign, which is very, very powerful. So in the factor line, always replace the proportional sign with the equal sign. And now we can progress further. So we have that the argon gas is 40 grams per mole, the O2 gas is 32 grams per mole, the argon gas is heavier. By mental math, 40 divided by 32, that's a factor of 5/4. And there is one more fact. The two balloons have the same number of moles. So the factor for the balloons with number of moles is also 1 time. And now we're very close to being done. We're going to use this equal sign. The factor for molecular mass is 5/4 times the factor of VRMS is 1, and that's equal to the factor for the temperature. So the factor for the temperature is 5/4 times. There it is, the temperature again. The factor is 5/4 times. And now we end up that the factor for the volume is 5/4 times. Argon has expanded. It's 5/4 bigger. 5/4 bigger than 20 liters is 25 liters. And so 25 liters is the answer to our problem.